This video we're going to talk about how to monitor the rate of reactions. The first one going to introduce is measuring change in volume of gas produced. So to measure the rate of reactions, actually we have two kinds of method. The first one, we can use it by measuring different kinds of physical properties. During a reaction, there will be some product produced or there will be some physical property change during the process. So based on these changes in physical properties, we can measure the changes in the physical properties, and then we can tell the rate of reactions. For example, if we have Mg added into HCl, so in the process, you'll find that we'll have salt and also hydrogen. Is that right? So in the process, you find that some gas is produced. If we can manage to measure the change in volume, because more and more gas is produced, if we can measure the change in volume, actually we can tell how fast the rate it is. And also, because there is gas formations, so we can also put the whole reaction in a closed system. We can also measure the change in pressure. Some of the reactions, we may have changes in the mass as well. For example, if we have like calcium carbonate added into acid, and then in the process you have calcium chloride, carbon dioxide and water. So in the process, you'll find that some of the carbon dioxide is given out. If this carbon dioxide, we allow it to go away, you'll find that the total reaction mixture of this one will getting lower and lower. So by measuring the change in mass, we can also to know the rate of reactions. Finally, some of the reactions, they may have color intensity change during the process. Maybe the color get paler and paler. For example, we have like permanganate, which is a OA, and react with sulfite ion, which is an RA. In the process, the purple color, of the permanganate will then become Mn2+, which is very pale pink. So you'll find that the color intensity will decrease. So by measuring the change in color intensity, we can also find out the rate of the reactions. Other than that, actually for all these, we are measuring the physical properties. But other than that, we can also, based on titrations, using something called titrimetric analysis, we can also monitor the rate of reactions. But in these kind of reactions, normally the reactants, they may contain acid and alkali. In details, we're going to talk about that later. So when you suggest method to monitor the rate of reaction, this one is the most important questions we're dealing with in this chapter. So normally we'll just give you reactions and asking you, can you suggest a method to monitor the rate of reactions? So basically, in the answers, I need you to provide three informations. First of all, you have to tell me by measuring what things. So the first one, by measuring change in, for example, volume, of the gas produced, with what kind of instruments, this one would be the second one. And also you have to tell them that, at regular time interval. That means, we are not measuring the change in volume, at the time zero and also at the end of the reaction. But throughout the whole progress, we have to know how the change in volume happens throughout the whole reactions. So therefore this three part is very important. Just in the following, I'll just give you two examples. For example, we can measure the monitor the rate of reaction by measure change in volume with gas syringe at regular time interval. So you see that we have three part, change in volume, gas syringe, regular time interval. Or you can change in gas pressure with pressure sensor at regular time interval. So this is what I expect from you, when you're asked to suggest a method to monitor the rate of reactions. Basically, the answer is composed of three parts. So first of all, we're going to talk about how to follow the progress of reaction by measure the change in volume of gases produced. So when we're going to use it, use this method, of course, you need to have a gas product. But this gas product is not enough, It have to be an insoluble gas. Because if it is a soluble gas, say for example soluble gas, we'll have some acid gas like SO2, CO2, Cl2. These kind of gas, they may redissolve, into the liquid. So if you redissolve into the solutions, then even if produce gas, it can't create an increase in the volume of gases in a change in volume significantly. So therefore, mainly we talk about insoluble gas like hydrogen in the process. So the reaction right now we are talking about will be the metal react with acid to give salt and hydrogen. Okay, so the volume of hydrogen produced will be measured by the gas syringe. So we have a gas syringe here. Remember, okay, this setup, okay, is very important to measure the time as well. So you can see a timer here. So in the process, when we drop this magnesium, okay, into the acid, okay, then the reaction will produce, okay, the reactions will start, okay, and then the gas will come out. So the gas coming out will push this plunger, okay, backward. So the volume, okay, will be indicated on the graduations of the syringe. Okay, so as time goes by, we're going to read how much volume of hydrogen will be produced in the process. Okay, so basically this reactions, okay, you can see that this setup, okay, you can see that we got a cotton thread hanging right there. Okay, because you remember initial rate, it should be having the highest rate. Okay, so we don't want to have some of the gas produced, okay, to leak out from the system. If we just open the stopper, or take away the stopper and then drop the magnesium ribbon and then put back the stopper, so in the process, okay, some of the gas produced may be leaking out very quickly. That's why you can see that, okay, we hang this magnesium ribbon like here, okay, clipping between the stopper and also the conical flask. We just slightly lift up the stopper, the cotton thread, okay, together with the magnesium ribbon will be allowed to drop down, so we can minimize, okay, the gas leaking out from the system. So basically the system here, okay, is very important, and you need to know how to sketch it. Okay, so normally 2 mark for this. Okay, basically you need to draw a conical flask, okay, and then you need a delivery tube, and then you just draw together with a syringe like this way will be all right. Okay, so the syringe like this. Okay, so this is the syringe. So you have to label the whole things. But not only this, if you just have these kind of things, okay, that would be not enough. Okay, so of course you have a magnesium. Okay, so you have a magnesium. So just like this is not enough, because the most important thing is the watermelon. Okay, it should be a melon. Okay, so you should have a timer with you. Okay, timer is very important in the setup. So basically, when you need to draw a setup, okay, to measure the change in volume, you need to have all these things include, okay, in your answer. Okay, so basically the setup will be like this. Examples. So right now, okay, we'll just give you some data, like the time, okay, the volume of gas produced. Okay, so because this one is the volume of gas is the dependent variables, okay, so therefore the volume of gas will be vertical in the x-axis. Volume of gas, remember, give them the unit, which is cm cube. Okay, so the other one will be the time. Okay, the unit will be second. Okay, so at the beginning, remember, all of them will start from 0 at this point, because this is a product time graph. Okay, product time graph. So therefore it will start from 0. So you put something like this, a smooth curve like this way. Okay, so actually when you look at the data, you can help you to know when will be the end of reactions. So you just check, starting at this moment backward, okay, all the volume of gas produced, okay, will be the same. So therefore the end of reaction should be here. The total amount of product form will be this one. Okay, so for me, okay, before we plot the graph, okay, I'll look at the data, okay, like this way, and then we'll highlight the most important one. Okay, so basically what you need to do, okay, name an apparatus used to collect and measure the volume of gas produced. This one we have mentioned just now. Pay attention to the spelling. Gas syringe. Okay, so this will be the gas syringe. Okay, and then what gas is collected in the process, because we're having HCl react with magnesium, so the gas, it will be hydrogen. This question, it doesn't say name the gas, so therefore you can also write H2 for this. Okay, sorry, you can write H2 for this. Okay, hydrogen like this. Okay, so you need to plot a graph. Remember, XY axis is very important. You have to label it, and then the whole reaction start from 0, the origin part. Okay, at what time the reaction complete? You don't need to rely on the graph. You just need to rely here. So there is some tips right here. Okay, so remember in the exam, most of the question actually you don't need to using the graph that you port. Okay, but porting a graph actually it use up a lot of time. Okay, so for this one maybe you have just 2 marks only. If you find that you don't have sufficient time, you just don't do it. Okay, you don't do the graph. You just use the data in the tables, okay, to help you to do all kind of maths. Okay, so calculate the average rate, okay, of formation of gas product. You see that average rate, you just need this data and also this data, right? 2-point form. Okay, so you just use 2-point form here, then you can do the calculation. Basically you just have 75 minus 0 over 35 minus 0. Remember this time we're having cm cube, so the unit have to be cm cubed per second. Okay, so you can see that actually we don't need a graph at all. Okay, so if you find out you don't have sufficient time, just skip the graph. Okay, so just one more example. This one is benzene diazonium chloride. Okay, you know what is that? Okay, so C6H5. Okay, later on you have to be sensitive. It is talking about something like this. Okay, so we have a N2 Cl. It look like this. Okay, together with the water. So these reactions, okay, you can find that contain a large excess of water. The equation you have N2 produced in the process. So N2, it is an insoluble gas as well. Okay, it is not soluble in the water, so we can use a gas syringe to help us to find this out. Okay, so you have time, okay, which will be the independent variable, and then the volume of gas will be the dependent variable. So remember, make sure you know which one is the x-axis and y-axis. Dependent variable all the time will have to be the y-axis. Before we plot the graph, okay, we look at which point onward, okay, the reactions finish. So it should be this one, because you see that 58.5 afterwards. So the average rate basically will be 58.5 minus 0 over 7 minus 0. Okay, so the unit for the one above, it will be cm cube, the one below will be minute. Okay, so therefore the final unit have to be cm cube per minute. Okay, so you need to plot a graph. You have to tell the maximum volume, okay, and then you have to tell the average rate. Basically it will be like that only. Okay, not that difficult. Oops, I make a mistake. Okay, that will be the first 4 minutes. Okay, so remember, don't just look at average minutes. Okay, average rate, you have to pay attention is any duration. So again, okay, it should be 51 minus 0 over 4 minus 0. Okay, for this case. Okay. So to summarize, okay, there are ways to monitor the rate of reactions. Basically can be categorized into 2 methods. One would be monitor the changes in physical properties. Say for example the volume change, the pressure change, the mass change, or color intensity change. Other than that, we can base on titrations. We can use titrimetric analysis to help us. So very important thing is when you suggest ways to monitor the rate of reactions, your answers have to be having 3 parts. One is change in physical property. Second one is what instrument you're going to use. Last one, you have to tell them that we'll do that at regular time interval. So the one that we're going to discuss today is monitor the change in volume with gas syringe. Okay, pay attention to spelling of gas syringe, and you have to know how to sketch this graph. One of the most important one is the timer. Okay, it's the timer. Okay, so we got a string hanging right there because we are afraid the volume of hydrogen produced is too much. Okay, and then we can push this plunger shooting out. Okay, so in this case that will not be something that we want. So therefore we have a thread here to hold the plunger back. Okay, prevent it from shooting out. Okay, so when we're going to use it, okay, when insoluble gas is formed. Okay, so it's not question mark. So when insoluble gas is formed, we're going to use this one. Okay, so just now you learned that hydrogen and nitrogen are insoluble gas. Those are suitable for using this setup to help. Okay, so that's all for this video. Bye bye.